Hello students, welcome back. The topic that we are going to learn today is skewness, moments and kurtosis. So in this part of the video, we'll only be learning about skewness, and then moving on we'll learn about moments and kurtosis. So let's get started. Okay, first of all we need to know that what exactly skewness is. So skewness is basically tells you about the symmetry in a distribution, or if we go through the definition, it says the measure of central tendency gives us an estimate of the representative value of the data. All right, the measure of dispersion gives us the idea of the variation of the data value or closeness of the value from central value. Skewness indicates the lack of symmetry in a distribution around some central value. So skewness basically tells you about the symmetry of a distribution. Now there are three types of skewness. The first we are talking about is positive skewness. So if the right tail of a frequency curve is longer than the left, the skewness is said to be positive, or distribution is said to be positively skewed. Okay, so when we talk about the positively skewed distribution, so this is how the positively skewed distribution look like, in which most of the values lies at the end of the distribution, or the outliers lies at the tail of the distribution. Alright, okay, so this is basically called positively skewed. In positively skewed distribution, the highest value is average value, which is mean. First average, which is mean. As we all know that we have first order averages, mean, median and mode. So when we talk about mean, median and mode around some central values, as it says, so positive skewness, in positive skewness, the largest value is of mean, then the median, and the least value, the smallest value, is of mode. So as you can see, this is my origin point. As I move further, I find out mode first, then median and then mean. Keeping in mind that median will always lie between mean and mode. The decision is taken by looking at the values of mode and mean, that what type of skewness it has. If the value of mean is greater than that of mode, or you can say that if the value of mean is the greatest among all two averages, that is mean and median and mode, so we say that the skewness is said to be right skewed or positively skewed. If we talk about negatively skewed, so if the tail of the curve is longer than right, the skewness is said to be negative, or the distribution is said to be negatively skewed. So this is how the negatively skewed distribution looks like. So in which the tail is more towards the left side of the distribution, and most of the values, or you say the most outliers, lies at the tail of the distribution, which is towards the left side. So the relation defined in left skewness or negatively skewness is that the mean value is the least value in the data, the median is always the mid value, and mode is the largest value, because the values goes from left to right, and as we move towards the right, the values get bigger. So the relation will be mean is less than median and median is less than mode. So in negatively skewed, the largest value of the all three averages is mode, then comes median, and then the last value is mean. So positive and negative skewness is determined by the value of mean and mode. We need to look at mean value and what is the value for mode. If the mode value is highest among the two remaining averages, which is mean and median, then we say that it is negatively skewed. But if the value of mean is largest than the value of median and mode, then we say that it is positively skewed. Moving on towards symmetrical, normal or no skewness. Alright, so if both the tail of frequency curve are of equal distance from some central value, the skewness is said to be 0. That means that it does not have any skewness, or the distribution is said to be 0 or normal. In this case, we say that mean, median and mode are all equal, and they both lies at the center of the data. So this is the shape of the data, in which you can see this is my central value, and both the tails are of equal distance from some central value, which is mean, median and mode. So that means that 50% of the data are in this half and 50% of the data is on the other half, and the central values are mean, median and mode. In this type of skewness, in this type of distribution, we say that all three central averages or all three first order averages are equal. That means that if the distribution is symmetrical, the value of mean, median and mode will be equal. And if it happens, we say it's a symmetrical distribution, or if it's a normal or no skewness, it has no skewness or zero or normal distribution. Alright, moving on. We need to know some of the important measure of skewness as well. So the following are the four important measure of skewness. Number one is called first Pearson coefficient of skewness. The formula is mean minus mode upon standard deviation. Second Pearson coefficient of skewness, which is equals to 3 times mean minus median divided by the standard deviation. Third coefficient is basically called the quartile coefficient of skewness. The formula for that skewness is Q3 plus Q1 minus 2 times Q2 divided by Q3 minus Q1. And the fourth coefficient is basically called the moment coefficient of skewness, which is represented by beta 1. And these are the value which is called mu, and these are read as mu3 square over mu2 cube, where mu3 is called the third moment about mean and mu2 is called second moment about mean. The moments about mean mu2 and mu3 are also called the central moment and are computed as mu2 is equals to summation f x minus x bar square over summation f, and mu3 is computed as summation f x minus x bar cube upon sum of f. Now as you can see, second moment reflects the formula of variance. So we always say that second moment about mean is equals to variance. Third moment about mean tells you about the skewness of the distribution. Alright, and the formula written out here is for group frequency distribution and for simple frequency distribution. Okay, so alternatively mu2 and mu3 can also be computed by the following relations. Now these relations are mu2 is equals to mu2 prime minus mu1 prime square, and mu3, the relation for mu3 is mu3 prime minus 3 times mu1 prime mu2 prime plus 2 times mu1 prime cube. Now mu prime is basically indicating the moment about origin. So we were first talking about moment about mean. Now mu1 primes and mu primes value indicates the moments about origin, and it is computed as mu1 prime is equals to summation fx divided by sum of f, mu2 prime is equals to summation fx square divided by sum of f, mu3 prime is equals to summation fx cube upon sum of f. Now as we go further for mu4, the value will be summation fx cube upon sum of f. Now if you look at the all three mu primes values, if the mu prime, if we have first moment about origin, it's reflecting the formula of mean, which is equals to summation fx divided by sum of f. The second moment about origin is equals to summation fx square. Alright, if it's written second moment, then moment about origin have value fx square divided by summation f. Third moment about origin, third moment fx cube divided by summation f. Now these are the formula for simple frequency distribution. You can use this formula for simple frequency distribution and for group frequency distribution. Now there's something you need to know before starting with an example, that beta 1 always have same sign plus or minus as of mu3. Now the value, because beta 1 actually decides the moment coefficient of skewness, so it should have same sign as of mu3, because if you look at the formula, just go back a little and look at the formula for beta 1. Here you have beta 1 formula. Okay, so it has the same sign as of mu3. Skewness is negative if measure shows negative result, and skewness if positive if measure show positive result. There is no skewness or distribution is symmetrical if measure shows zero value. Now that exactly means that if beta 1, if we calculate the coefficient of skewness and we find out that the results are coming in negative values, that means that it is indicating that the skewness is negative. And if the values after the calculation are positive, it means it shows positive results, showing it is a positive skewness or positively skewed. But if the values are coming as 0, that means that it has no distribution, or this distribution is said to be symmetrical. Moving on, we'll now consider an example to find out first 3 coefficient of skewness, and then we'll move on towards the third coefficient of that is the fourth coefficient of skewness or moment coefficient of skewness. So we'll take an example here which says that you need to find out first 3 coefficient of skewness on the following data. Now this is the data given. As you can see, the values are 42, 68, 80, 75, 54, 62, 89, 72, 80, 80, 75 and 65. This type of data is actually called ungroup data. We refer it to case 1 data. Okay, we need to calculate the first 3 coefficients, so which is first Pearson of coefficient. The formula is mean minus mod upon sigma. Second Pearson coefficient of skewness is 3 times mean minus median upon sigma, and the quartile coefficient is equals to q3 plus q1 minus 2 times of q2 divided by q3 minus q1. Now, in order to find out first 3 coefficient, we need to know the value for mean, median, mod, quartiles and standard deviation. So the formulas for all these parameters are x bar, which represented as mean, is equals to summation x by n. Now it's an ungroup data, so we're using case 1 formula or ungroup formula, which is equals to summation x by n. The median formula is n plus 1 divided by 2 th value. Now as I told you before, that this formula only indicates the position of the value. You need to first array the data in order to find out median, and then using this formula will give us the position value. We'll go back into the data and we'll then find out what an exact median is. As you know, that mod is the most repeated value when it comes to ungroup data. For quartile, q of I equals to I times n plus 1 divided by 4. Now also, since median and quartile have some sort of relation, and the same methods are used to find out quartiles as of median, because qi in this case, what we used to do is we used to array the data first, and then we substitute this formula. We use this formula to find out the position value, and then by going into the arranged data we find out the exact value of quartile. Now in this case, in skewness, in quartile coefficient of skewness, we need to find out all 3 quartiles, right? So we're going to be substituting q of I equals to 1 for first quartile, I equals to 2 for second quartile, and I equals to 3 for third quartile in order to find out all 3 quartiles. Alright, so the formula for standard deviation, now this formula is basically called the definition form, or you can say that in order to find out standard deviation, we need to find out variance first. So standard deviation is the square root of variance. The formula is under root summation x minus x bar square over n, which is the definitional form, or you can use the computational form, which is equals to under root summation x square by n minus sum of x by n whole square. Okay, so I've already calculated values for mean, median, mod and all my parameters, and these are my results. Mean is equals to 68, median equals to 72, and mod is equals to 80. First quartile is 58, third quartile is 80. Now out here I haven't calculated second quartile because I already know, and I hope that you should already know by now that second quartile is equals to median value. So if we have already calculated median, we don't need to calculate second quartile again. We just can say that using relation q2 is equals to median, which will be equal to 72. So I haven't calculated second quartile value. And standard deviation, which I have calculated, and find out the answer, which is equals to 14.087. Now what you can do is that you can calculate all these parameters yourself to find out your answers and compare your answer with the answers given here. The next step now is to substitute all these values into these formulas and find out our results. Okay, so I've substituted the value, which is 68 minus 80 divided by 14.087, gives me a result of minus 12 divided by 14.087 equals to minus 0.518. If I talk about the second coefficient, which indicates 3 times mean minus median, which is equals to 3 into 68 minus 72 divided by 14.087, gives me a result of minus 12 divided by 14.087 equals to minus 0.8518. And lastly, the quartile coefficient, which is equals to 80 plus 58 minus 2 times of 72 divided by 80 minus 58, gives me a result of minus 0.2727. Now, as you can see that all the answers I got are of negative sign, which is indicating that the distribution is said to be negatively skewed. As I told you earlier, that in skewness, when we are talking about its measure, let's say if any of the coefficient is negative, then all the coefficients should be negative in order to declare that it is a negatively skewed distribution. It cannot be a case where one coefficient is said to be positive. Let's say if the first coefficient is positive and the second appears as negative, third appears as positive, so we need to look at a calculation that we have done, because for all measures the values should be negative. If these all values are negative, and it should be negative in order to declare it as a negatively skewed distribution, as in this case. If all of these values are positive, then we say that it is a positively skewed distribution. And for symmetry, for symmetrical distribution, it is important that all three values, when we are talking about only first three coefficient, it should be equal to 0. If it is not equals to 0, we cannot say that it is a positively or a symmetrical distribution. So it says that all three values should be negative, or all three values, if only we are talking about first three coefficient, if there is negativity, or if it is negatively skewed, then means all three should be negative. If it is positively skewed, if let's say the distribution is positively skewed, then all the coefficient of skewness should be positive. And if it is symmetrical, then all the answers or all the skewness, coefficient of skewness is positive. So by the calculation, we say that the distribution is negatively skewed. In statistic, negative sign appears as a nature, and it defines that what nature it has. Negative signs indicate that the distribution is said to be negatively skewed. Alright, that means mod has the highest value if we talk about relation with mean, median and mod. And in this case, you can also see that value of mod was the largest, then we have median, and the smallest value was of mean. I hope that you have understood how to calculate first three coefficient of skewness, and now you will be able to solve first three coefficient of skewness of ungrouped data easily. Thank you so much.